ladies and gentlemen. This is Dr. Umar Ashkar Suleiman with the topic understanding exponential and logarithmic functions. Lesson objectives. First of all, we are going to define the exponential and logarithmic function, identify their properties and their inverse relationship, show their connection with hyperbolic and trigonometric functions, and we will try to sketch the graph of these functions. Now, exponential function. As you can see, exponential function is a function of the form f of x is equal to ex, where e is approximately 2.71828, a very important number in mathematics. The domain is negative infinity to positive infinity, where it gets its values, and the range, what it gives, the range of set of values is from 0 to infinity. It is always positive and increasing, and it also passes through the point 0, 1. This is the graph of an exponential function. Secondly, the natural logarithmic function. We have two types of logarithmic functions. The first one, this one is a natural, and the natural logarithmic function is a function where the base is e, the same e we explained earlier. Now, is the inverse of the exponential function, and it is written as y is equal to ln, as natural log x, which is equivalent to saying exponential y is equal to x. Again, the domain is from 0 to infinity. The range, negative infinity to infinity, also have negative numbers. This passes through the point 1, 0, and it's slow growth for large x. Thirdly, hyperbolic function. Hyperbolic function are this function. The sign, the basic ones are sine, hyperbolic sine written as sine h is given by this in terms of the exponential function. Hyperbolic cos in some cases called, and also the hyperbolic tan, which is derived from hyperbolic sine and hyperbolic. These are the graphs of the hyperbolic functions. Now, the connection between trig and exponential function. A man named Euler discovered that there is a connection between exponential function and the normal trig function sine. That is the function in the left. As exponential ix is equal to cos x plus I sine x. These are the ordinary trig functions, where I is the square root of a negative number as a complex number, which implies that cos x is that, sine x is that. Also, on the right hand side, we have the hyperbolic function in terms of the exponential function. You can see the hyperbolic cos or cos x is equal to that. Hyperbolic sine x is equal to that quotient x. And from these two, we have this relationship between hyperbolic cos and the normal trig for cos, as well as the hyperbolic sine and normal trig sine. This is the graphical comparison. This is the graph of hyperbolic tan of x. You can see that it is bounded by plus or minus 1. This has cos and sine are bounded by x and minus 1. And cos x is even, the minimum at 0, 1, and sine x is passes through the origin. Takeaways are exponential function and are inverses, and ln, that's natural log function. Hyperbolic function are exponential similarities, analogous to of trigonometric function. Trig function can be expressed using complex exponentials, and the graph of hyperbolic function resembles trig function ones but with exponential curvature. Coming up next, video 2, we are going to define and explore hyperbolic function, derivative of identity and relation, compare with ordinary differential equation, and plot and interpret their graphs in details. Thank you.